Okay, so this was the sheet that we started in class on Tuesday, and I believe we got through number 3, but that we were rushing through number 3. So I'm going to go back to number 3 and start there. So the question is, when is the function decreasing? So f is decreasing when f prime is less than 0. Okay, so that's what we're interested in. So the first thing we're going to have to do is find f prime. So this is going to be a quotient rule. So it's the bottom times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, all over the bottom squared. Okay, so we want to set that equal to 0. Over here, there's more room. And while I'm at it, I'm going to distribute this negative. Okay, so I'm saying that equal to 0. So when I cross multiply, I'm going to get and I'm going to combine like terms now. So an x squared and a negative 2x squared is a negative x squared. X and negative x cancel, and I just have a negative 2 equals 0. So I'm going to, it doesn't matter, I'll just bring the negative 2 over. So negative x squared equals 2, divide both sides by a negative, and I get x squared equals negative 2. Well, it's impossible for me to take the square root of a negative number, so that would mean that there are no critical points. So if the question was where are the critical points, there are none. Okay, but the question is asking when is the function decreasing. So we want to know when is f prime less than 0. When is f prime less than 0? Okay, so let's make our wiggle graph with f prime, and now we have no values to put on this wiggle graph because there were no critical points, so that allows you to do any point you want. So remember, this was the derivative over here, so I'm just going to choose 1. So f prime of 1 is going to be a negative 1 squared minus 2. That gives me a negative 1 minus 2, which is negative 3. So that means for all values, the function is always negative, and therefore it is always decreasing. So you would say that it is decreasing from negative infinity to positive infinity. And that means the graph looks something like that. And there's other ways that it can look, but that's like just one example. Okay, so we're up to number 4 now. So we need intervals of increasing and decreasing. So again, we need the derivative. So f prime is 3x squared minus 6x. Set that equal to 0. Factor out a 3x. And we will get that x equals 0 and x equals 2. So we're going to make our wiggle graph. And we're looking for increasing, decreasing, and f prime tells us about that. So if we, here's the f prime here. So if we do f prime of negative 1, we'll get 3 times 1 minus 6 times negative 1. So 3 plus 6, and that's 9. And then if we do f prime of 1, we get 3 minus 6, that's negative. And if we do f prime of 3, we get 3 times 9 minus 18, that's positive. So we need to say when is this function increasing and decreasing. So it's increasing here, decreasing here, increasing here. But it says state the interval, so we have to write it as increasing from negative infinity to 0, and then from 2 to infinity, and it's decreasing from 0 to 2. Okay, we're up to number 5 now. So we want to know when is it concave up or down and find points of inflection, and that's the second derivative. So the first derivative will be 4x cubed minus 12x squared. The second derivative is going to be 12x squared minus 24 x. So we want to set that equal to 0. And we can factor out a 12x. Okay, we're going to get two solutions, x equals 0 and x equals 2. So here's my wiggle graph with 0 and 2. And for concavity and points of inflection, it's always in the second derivative. So here's the second derivative right there. And now we're going to just plug in some values into there. So why don't we try -1 first. So f double prime of -1 will give me 12 plus 24. That's positive. F double prime of 1 is 12 minus 24, so that's negative. And f double prime of 3 is going to be 12 times 9 minus 72. So 108 minus 72 is positive. Okay, so now let's look at the question. Where are the points of inflection? So there's sign changes everywhere, so you would say that there are points of inflection. You would write it out, not use that, at x equals 0 and x equals 2. And this, wherever it's positive, it's concave up and concave down, but we need the intervals. So it's going to be concave up from -infinity to 0, and then from 2 to infinity. Isn't this the same answer as the previous question? I think it is. And concave down from 0 to 2. Okay, and now we're up to number 6, so we need points of inflection, so that's the second derivative. So the first derivative is this. The second derivative is this. We're going to set that equal to 0. Factor out a 6x. Okay, so we're going to get that x equals 0 and x equals 1/2. Make a wiggle graph. And it's asking about points of inflection, so that's the second derivative. Okay, so that's my second derivative right there. And we're going to put values into that function. So f double prime of -1 will give me 12 plus 6, so that's positive. F double prime of 1/4 will be 12 times 1/16, right, because 1/4 squared is 1/16, minus 6/4. So this gives me 12/16 minus 6/4. So if I find a common denominator of 2, so if I divide 12, it'll just be easier for me to just do 2 minus 1.5, right? I know it's positive. And then, make some room. Wait, how could that be? It was 12/16. Sorry, let me fix that. 12/16. Just like put that over 1. Let me go back. I knew something wasn't making sense here. Okay, so 12/16. Oh, so I'll leave that. So 12/16 minus 24/16. So you can see it's negative. And then we need to do f double prime of 1. We get 12 minus 6, so that's positive. Okay, let's go back and look at the question. Find all points of inflection. So there's a point of inflection wherever there is a sign change. So points of inflection here and here. So at x equals 0 and x equals 1/2. Okay, and this is the back of the sheet, so we'll do number 13 first. So that's concavity and inflection points. So again, that's going to be the second derivative. So f prime is this. And that means the second derivative is this. I'm going to set that equal to 0. I'll bring the negative 12x over, and I get x equals 1. So here's my wiggle graph, and I'm going to be using the second derivative. Okay, so f double prime of 0 will be 12. F double prime of 2 will be negative 24 plus 12, so that's negative. So therefore, make some room here, there's a sign change, and therefore there is a point of inflection at x equals 1, and we need the intervals of concavity. This is concave up, concave down. Do not do that on the test. You have to write it as an interval. So it's going to be concave up from negative infinity to 1, and then concave down from 1 to infinity. Okay, and we have one more to go, and that's number 14. So again, we need concavity inflection points. So the first derivative is going to be this. Second derivative is this. Set it equal to 0. And we get x equals plus or minus, because we're going to take the square root of 2. Okay, this function they just called g. It doesn't matter. It's f or g. It's the same thing. Okay. Alright, so we could do g double prime of negative 2. And we get 2 times 4 minus 24. That's positive. G double prime of 0, we're using this right here, is going to give us negative 24. And then we'll do g double prime of 2. We'll get 12 times 4 minus 24. 48 minus 24 is positive. Okay, and therefore we can say that there are points of inflection at x equals plus or minus radical 2, because there were sign changes. And for concavity, for concave up, we're going from negative infinity to negative radical 2, and then from radical 2 to infinity. And we're going concave down from negative radical 2 to positive radical 2. And that completes the classwork from Tuesday.